Number 4. So again, in the box at the top, you've got what we were given, that there's a sled which weighs 1,250 kilograms and a slope of 100 meters and a drop in height of 12 meters. And they're asking what is the velocity when the sled reaches the bottom, and we're assuming no friction. So we know gravity is 10 meters per second squared vertically, and most of that is going to act against the slope, given it's quite a gentle slope, but some acts along the slope, and it's this bit that acts along the slope that we're interested in, because that's what's going to be accelerating the sled. So using sine again from SOHCAHTOA, we get that the acceleration along the slope is gravity times the sine of theta. So again, the opposite in this case is 12 meters, and the hypotenuse is 100, and so the acceleration along the slope is gravity 10 times 12 divided by 100, which comes out at 1.2 meters per second squared. The next equation I couldn't find on your sheet either, which was final velocity squared equals initial velocity squared plus 2 times the acceleration times the distance, or VF squared equals VI squared plus 2AD. I did look for this on your sheet, but I couldn't see anything, so this was the only way I could work out how to calculate the velocity at the end. So it may be that I missed it on the sheet, or that it's described in a different way. What we're trying to work out is the final velocity. We know the initial velocity is 0, and we know the acceleration because we've just worked that out, and we know the distance because that's given to us as 100 meters. So if we calculate that, that gets to 0 squared plus 2 times 1.2 meters per second squared times 100 meters, or 240 meters squared seconds to the minus 2, so per second squared. Now I've used the units in here because it's helpful to make sure that we're keeping track of them, because the final velocity then is the square root of 240 meters squared seconds to the minus 2, or 15.5 meters per second. And so we've got the right units, we know that we've done that right, and that's one of the answers. So hopefully that helps.